Today's lesson is on how to change forms, going from exponential form to logarithmic form. A logarithm is a new type of function that we're going to be learning about. So let's get right into this. So right here we see exponential form. We have a base raised to a power, and then we have the answer over here. So we can rewrite this equation as a logarithmic equation. First thing we do is we write down the word log, which stands for logarithmic. Then we start at the base. And the base is a subscript number that goes below the g like this. So this is read log base 2. So we start at the base, and then we go around in this little circle helps us to remember the orders. We start here at the base, and then 8 is what we write next, and we write it on the same line as the log. So we have log base 2 of 8. Then we put in our equal sign, and then we finish a log with the exponent. The answer to a logarithmic problem like this is going to be an exponent, in this case 3. So again, we start at the base, and then we go around in the circle, and then up and ending up with the exponent. Now this number, when you're in logarithmic form, this number right here is called the argument. This is the base. And the answer to a logarithm, that is your exponent. A logarithm represents an exponent. Okay, so now let's go the other direction. This time let's go with log base 3 of, let's go with 9. So 3 to the second power equals 9. So let's go over here and let's change this to an exponent. Again, we start here at the base, just like here we started at the base. We're going to start at the base. So we're going to write the base first. Go around in the circle to the second power, and it's going to equal the argument. This is the base. This is the exponent, aka power. And if you're looking at what this number would be called, this would be called the argument from a logarithmic problem. Okay, so let's take a look at another example here. This time we have a fractional exponent. We do it the same way. We're converting it from exponential to logarithmic. So log, start at your base, and go in your circle. Log base 216 of 336 equals 2/3. Okay, so that's how you convert from exponential to logarithmic to exponential. Now, what do we do when we're solving a logarithm? So the x variable that we're solving for could be in 3 different places. It could be in the argument, it could be in the base, it could be over here in the exponent or answer of a logarithm spot. So we're going to set up 3 different types of equations to solve. So we just convert this to exponential, so 2 to the 3rd power equals x. And so 2 to the 3rd power, x equals 8. Okay, let's take a look at this one. Here we have x to the 3rd power equals 8. And now to solve this one, we're going to cancel out the 3rd power by going to the 1/3 power on both sides. Those cancel, so we get x equals the cube root of 8, which is 2. And then finally, again, we're going to switch this to exponential, so we're going to have 2 to the x power equals 8. Now to solve this one, what we want to try to do is get the bases to be the same. So 2 to the x will stay the same. And on this side, we can raise this one to 2 to the 3rd power, which is 8. So once you make the two bases the same, if possible, then you can set the exponents equal to each other. The rule is base m equals base n. And so if the bases are the same, you can set m equal to n. So that's what we're going to do here. The bases are the same, so we're going to set x equal to 3. So when you're solving and the x is in the exponent, one method that works some of the time is making the bases the same. And once you do that, then you can set the exponents equal to each other. So real quick, here are a couple things that you need to keep in mind when dealing with logarithms. So first of all, I rewrote the conversion using b, x, and y, so you can see where they go in this diagram. But in order for us to have a legitimate logarithm, b, the base, has to be greater than 0. If b is 0 or negative, then the answer would be no solution. X must be greater than 0, argument, and b cannot be equal to 1, which means it could be a fraction, like a half, okay? But we will not be looking at b equal to 1. Okay, see you in class tomorrow. Come with your questions.